Hello everybody, this is just a quick video to help you with this Khan Academy practice set called Derivative as a Limit. So this is really the heart of the theoretical background of what is a derivative and how do we find it using the limit approach. So this we're calling the formal definition. This is the formal definition here. I think I can still write. This is the formal definition of a derivative, and we'll call that f prime of x. So when they say like find the derivative using a limit approach, they're talking about this equation right here. As we said before, and you can look down here at my little drawing, bad as it is, that it's all about that secant line that is some fixed point. We're finding the derivative right here at this point, made very dark now. That point is the point at which we're trying to find the tangent to that line, to that curve, the tangent line to that curve, by allowing this point to float closer and closer. Now this point is just a plus a little bit we're calling h. Our textbook calls it delta x for the change in x, which is kind of sensible, but lots of other people find it easier just to use a single letter rather than sort of two symbols. So many of my videos have this, and Khan uses it anyway, so we can get used to that. So it's a is our fixed point. This a plus h is our floating point that we let that delta x, that h, that little tiny bit, get less and less and less and less by letting it go to 0. So as h goes to 0, what's the limit of the slope of this secant line? Now what happened down below? Usually that's like x1 minus x2 down below. Well, think about it. Our x is a, or in this case, our x is, that's our variable that we're allowing to float. That's the a plus h, and then we're subtracting a from it. So what is a plus h minus a? It's just h. So we've done that math for you. It's always what it is. It's just the change in x down below, which is our h amount. That's our delta x. Up here is the delta y. Okay, so how do we answer this? If you look very carefully, this is the limit as h goes to 0, so that's our formal definition. If we click to the next problem and it gives us like an x going to an actual number, we're going to skip over that because there are two ways to do this, and we're focusing on the h go to 0 method. So we're only doing things that go to 0. We shall see. All right, so then what's happening here? Well, clearly this is our a plus h equation. A plus h is put in for the variable, so this is telling us that the original function that we're finding is 2 to the x. This is the point at which it's being nailed down, so that means our x is 3. So this is just a way of saying that at the point where we're looking at 3 comma 2 to the third power, that would be 8. The point is 3 comma 8. We're finding the derivative. So it looks to me like that would be not this one, but this one right here. We're finding the derivative at 3, where the original function is 2 to the x, okay? So hopefully we'll get confetti here. Yes, we do. We're going on to the next question. This is an x going to 5, so that is not an h going to 0. So we're just going to skip that. Let me just, I'm just going to pick a random wrong number, and then I'm going to say move on, okay? And this is one that, again, unfortunately is going to a number. So I'm just going to click one incorrectly and then move on. And here's an h go to 0 method. So just do the h go to 0 method ones. So again, you can see we're looking for something plus h. So I don't like this x plus h thing at all. And then I'm looking for the function that it might be. So if we're subbing in, like in this case, 3 plus h, it looks like we're at 3. We're going a little bit away from 3. The squaring of that indicates that the original point was 3 squared going to 9. So, oh yeah, so I mean they've given us this up here. So I'm backwards engineering from the answers, but clearly we're at 3, and then we're going to x squared. So when we think of 3 plus a little bit, 3 plus h, it's pretty clear that that is going to be this one right here, okay? And we're good. So hopefully that is helpful, and good luck on that homework.